Hi, in this video, I'm going to talk about the confidence interval for the mean. So as we studied sampling distribution, we want to know the population parameters. So this is a population data. And from the population data, we want to know the population mean mu, population proportion p, and population standard deviation sigma. But in many cases, we don't have the population data or it is not possible to obtain the population data. Then instead, we get the sample from the population. So from the sample, we calculate the sample mean x bar, sample proportion p hat, sample standard deviation s. And these are, we call the statistic. And these population parameters, mu, p, sigma, that we call the parameter, population parameter. On the other hand, the sample mean x bar, sample proportion p hat, and the sample standard deviation s is a sample statistic. And this is a point estimator. So that being said, we want to know the population mean mu, but instead we have the sample only. So from the sample, we calculate the sample statistic x bar. So then we say that we estimate the population mean mu by using the sample statistic x bar, okay? But in many cases, as you expected, the population mean and the sample mean cannot be equal, okay? So for example, we want to know the population mean, the average income in Manhattan. Let's say the God knows the population mean, and let's say that is a $120,000, okay? But you get the sample, let's say that you randomly select 100 people and you ask that their income, it turns out the sample mean is $110,000. So they are different. But when we repeat this process, then we get the many x bars. So x1 bar, x2 bars, so on and so forth. And when we get the many samples, and then we take the average of the sample means, then it will be the same as a population mean. But there is a condition, the sample mean, when you collect the sample has to be unbiased. So that we can denote mu of the x bar equals population mean mu. But as you notice, the sample mean in many cases is not equal to the population mean. We want to estimate the interval. So that being said, we want to find the lower bound and the upper bound. And we expect the population mean would be located between this lower bound and the upper bound. Then how can we estimate the confidence interval? Well, from the sampling distribution, we studied this one. The sample mean x bar follows normal distribution with the mean equals the mu of the x bar. That's the same as a population mean mu. Standard deviation sigma of the x bar. That's the same as sigma over square root n. That's by the central limit theorem. And we need to have the condition the sample size is greater than 30. So sample is large enough, then the sample mean follows normal distribution that we call the central limit theorem. Okay, so there are two possible cases. You know the sigma, sigma is known, and you have a large sample, then you can use a normal distribution. But if you don't know the sigma, so sigma is unknown, then you cannot use normal distribution anymore. So you cannot use normal distribution. Then instead, you need to use a t distribution, student's t distribution. So I'm going to talk about the both of them. But when you take a look at the question, you first need to check whether the sigma is known or unknown. And based on that, you check that whether you can use a normal distribution or you need to use a t distribution. In general, the t distribution is more conservative than the normal distribution because the normal distribution requires two strong assumptions, such as the sigma is known. Think about it. We don't have the population data, but how can we know the population standard deviation, right? That's unnatural. So that's why, in general, it's more realistic that we don't know the sigma and we use a t distribution. So let's solve some question. The first question is following. If sample mean is 99 and we somehow know the population standard deviation, which is 11, and sample size is equals 11, and we assume that the x follows normal distribution, then can we construct a 95% confidence interval? Yes, by using the normal distribution. And the formula is the following. So x bar plus minus margin of error, then x bar minus margin of error, that's the lower bound, X bar plus marginal error, that's the upper bound. This is lower bound and this is the upper bound. And where this margin of error is Z alpha over 2, that we call the critical value, times sigma over square root n, that we call the standard error. So let's calculate it. So here, the margin of error is the following. We first need to find the Z alpha over 2, but as you study from the sampling distribution, let me visualize it. So this is a standard normal, and here's a mean equals 0. And this shaded area is a 95%, okay? And then as you notice, the left one and the right one, each of them is a 2.5%, okay? Why is that? Under the distribution, it has to be 100%. So 100 minus 95 is a 5%, okay? And then you divide it by 2. Why we need to divide by 2? Left one and the right one. So they are equally distributed. So 2.5%, 2.5%. Then this is a critical value, Z alpha over 2. In this case, alpha is 100 minus 95. This is a alpha. And then Z alpha over 2, then Z.025, 2.5%, okay? Then can we find this Z.025? Yes, by using the Excel. So here, norm inverse, 0.975, mean equals 0, standard deviation equals 1, then it gives you the Z, 0.025, that's the critical value. And you may ask me, why did you put the 0.975 instead of the 0.025? Well, Excel is calculating from the negative infinity to here, and when I put the 0.975, that is a 2.5% plus 95%, then this shaded area is a 97.5%. Then it gives me this number. Okay? That's why I need to put 0.975. So let's calculate this Z star, or the Z critical value. Put the equality, norm inverse, 0.975, mean equals 0, standard deviation equals 1. Then I have 0.95996 something. Up to 3 decimal places, that is just 1.960, okay? Then we need to find the sigma over square root 10, the standard error. And then the standard error is the following. Sigma is known as 11, and then sample size equals to 11 too. So I think that it's better. Okay, never mind. So over square root 11, okay? Then I need to have a space. So then we can calculate the margin of error. So Z alpha over 2 times the sigma over square root n is 1.96 times 11 over square root 11. So let me calculate the margin of error by using this Excel. So 1.96 times 11 over square root 11. Because the sample size is not enough, we need to have the assumption then X follows normal distribution. Otherwise, we cannot use a normal distribution. Okay? So the margin of error is 6.5 something. Then we're done. Sample mean is a 99. So 99 minus this margin of error, that gives me the lower bound, and 99 plus margin of error, that gives me the upper bound. So let me calculate it. So take a look. Equality, put the equality here, 99 minus this value, 6.5 something, and then 99 plus this margin of error, 6.5 something, that it gives me the upper bound. So up to 2 decimal places, I got 92.50, that's the lower bound, and the upper bound is a 105.50. Then how do you interpret this 95% confidence interval? Well, we are 95% confident that the true population mean, mu, would be located between the 92.5, 105.5, okay? All right, so let's solve the following question, question number 2. So a bottled water distributor wants to estimate the amount of water contained in 1 gallon bottles purchased from a nationally known water bottling company. The water bottling company's specifications state that the standard deviation of the amount of water is equal to 0.03. So you can denote the sigma is a 0.03. So I would say that this is a question for question. So it is weird that we know the population standard deviation, okay? But let's practice to solve this question. And a random sample of the 50 bottles, so that means n equals 50. And then the sample mean X bar is known as 0.941, okay? Now the first question, construct a 90% confidence interval. So it's exactly the same question. We can use a normal distribution. Why is that? Sample size is large enough and we know the population standard deviation. That satisfies the condition. That's why we can use normal distribution. Then here, X bar plus minus margin of error. And this margin of error is Z alpha over 2 times the sigma over square root n. And this Z alpha over 2, now alpha is 100 minus 90%, that's a 10%, and 10% divided by 2 is a 5%. So Z 0.05 times the sigma, which is a 0.03, over square root 50, okay? And then this Z 0.05, again, you can use the Excel and find this critical value. So let me show you. Or you can visualize the normal distribution to avoid the mistake, but I believe that now you can do it by yourself. So in order to find this Z critical value, in this case, let me put the 0.05 and mean equals 0, standard deviation equals 1. Then you have a negative, right? Because you found the negative critical value. But you just need to drop the sign. For the critical value, it has to be positive. But let me find the positive one. Norm inverse 0.95, mean equals 0, standard deviation equals 1. Okay, so then we have the positive one. Again, you may want to draw the graph to avoid the mistake. So this is a standard normal distribution, and this is a 90%. And what I found is that the negative critical value, negative 1.645 up to 3 decimal places, and this is a 5%, and this is a 5%, and I found the positive one too, 1.645. So that's why the first one I put the 5%, then I got this negative 1.645. The second one, the positive 1.644, that one I put the 0.95. That's why I got the 1.645. Okay. So then let me calculate this thing. Critical value times a standard error. So 1.645 times 0.03, that's a standard deviation over square root 50. Then we get the margin of error. So the margin of error up to 4 decimal places is a 0.0070, okay? Then we're done. X bar minus, so X bar is a 0.941, 0.941 minus 0.007, that's the lower bound. 0.941 sample mean plus 0.007, that's the upper bound. So let me calculate it. 0.941 minus 0.007. Okay, I need to put the equality here. And then 0.941 plus 0.007. Oh, by the way, in general, you better keep the full decimal places, but in the last step, you round it up to the 4 decimal places or 3 decimal places based on the question's instruction. Okay? But in this case, I just want to make it simple. That's why I round it up in the middle of the process. But in general, you better keep the decimal place, every single decimal, and then in the last step, you round it up to the 3 decimal places, 4 decimal places based on the question. So here we found the lower bound is 0.934 and the upper bound is 0.948. So how to interpret this one? Well, we are 90% confident that the true population mean amount of the water would be located between the 0.934 gallon and 0.948 gallon. Okay? Now let's solve the question number B. Everything is the same, but we want to construct a 99% confidence interval. Then you just need to update this Z critical value. So let me copy and paste here. But what we're gonna do is I'm gonna change this Z alpha over 2. Now it becomes here. This Z alpha over 2 becomes Z 0.005. Why is that? Well, 100 minus 99% is a 1%, and you divided by 2, then alpha over 2 is, this is alpha over 2 is 0.5%. And the 0.5% is basically same as 0.005. So then let me calculate this Z 0.005. Again, you can find the negative one or the positive one. Doesn't matter, but you need to know that the critical value has to be positive. So let me find the negative one, but I'm going to drop the sign. The norm inverse 0.005, mean equals 0, standard deviation equals 1. Then I got negative 2.576 up to 3 decimal places. Then I drop the sign, that is 2.576. Okay, and times the 0.03 over square root of 50, then I can find the marginal value. So let me find the marginal value real quick. So they put the equality 2.576 times 0.03 over square root 50. That gives me the marginal value, that is 0.0109. Okay. Then do the same thing. We have the sample mean 0.941 minus 0.0109. So let me keep the 4 decimal places. And then the upper bound is 0.941 plus 0.0109. Then we can find the upper bound. So let me calculate the lower bound, the upper bound, and then compare with the question A. So put the equality 0.941 minus 0.0109. That's the lower bound. And the upper bound is 0.941 plus 0.0109 that I have an upper bound. So let me put the answer here, 0.9301. That's the lower bound. Upper bound is 0.9519. But when you compare the 90% confidence interval with the 99% confidence interval, what do you see? Well, this becomes a wider. Okay. Lower bound here, 0.934 becomes 0.9301. Upper bound 0.948 is becomes a 0.9519. So that means that when you raise a confidence interval, the confidence level, the interval becomes wider. That's the key. Now I can twist the question. What if you have a larger sample than 50? Well, then you see that the marginal value, the formula, when the sample size larger than before, so n increases, then this marginal value decreases. Okay, so when marginal value decreases, then this confidence interval becomes narrower. Okay. All right, so let's solve the another question. Question number 3. The quality control manager at a light bulb factory needs to estimate the mean life of the large shipments of the light bulbs. The standard deviation is 78 hours. A random sample of these 36 light bulbs indicated sample mean life of the 240. But first, we know the population standard deviation. They let you know the population standard deviation, which is 78. And the sample size is large enough, the 36, and the sample mean X bar is 240 hours. That means we can use a normal distribution. It's the same question like question number 2. So it's straightforward. So the first question, we want to construct a 95% confidence interval. So then we first need to calculate the marginal value, which is Z 0.025, 2.5% times sigma over square root n. Okay, so that is 95% confidence interval. We already found this the Z value, which was a 1.96. So we can reuse that number. So you don't need to calculate every time you find this Z critical value. This is just 1.96. So when you solve a couple of questions, then you automatically memorize this Z critical value. So 95% is a 1.96, 90% is a 1.645. something like that. And then the sigma is 78 and over the square root 36. Okay, so that gives you the marginal error. So let me calculate it. Again, you can use the Excel to find this value, 1.96, put the equality, 1.96 times 78 over square root 36 is just 6. So the marginal value is 25.48. That means the confidence interval is the following. 240 minus 25.48, that's the lower bound. 240 plus 25.48, that gives you the upper bound. Okay, so let me calculate the lower bound and the upper bound. So 240 minus this marginal error, that's the lower bound. 240 plus this marginal error gives you the upper bound. So the lower bound is a 214.52. Upper bound is 265.48. So then interpretation is we are 95% confident that the population mean life of light bulbs in the shipments would be located between the 214.52 and 265.48 hours. Now, question number B. Suppose the standard deviation changes to 60. It was a 78, but it decreased to 60. And then we want to construct the 95% confidence interval. Then margin of error, z.025, sigma over square root n, but sigma is a 60, and over the same sample size square root 36. So let me calculate this one. This z is a 1.96. So margin of error is you pick up any cell and then put the equality. 1.96 times 60 over 6, square root 36 equals 6. That's why I put the 6. So margin of error decreased to the 19.6. It was a 25.48. So this is 19.6. Then the confidence interval is 240 minus 19.6. And then 240 plus 19.6, it is the upper bound. So let me calculate the lower bound and the upper bound. So lower bound is 240 minus 19.6. And then 240 plus 19.6 is the upper bound. So the lower bound is 220.4, upper bound is 259.6. Now, when you compare the previous confidence interval, what do you see? It becomes a wider. Why is that? Standard deviation. Let me double check. So 1.96 times 1.96 times a 60. Standard deviation is 60, and over 6, that is a 19.6. And then the previous one, 1.96 times a 78. So yeah, so margin of error decreases. That's why we have a narrow, sorry, I said that the confidence interval wider. No, that's not true. So this one is a 214.52 and 265.48. That's the question number A, is the confidence interval when the sigma is 78. But when we have a sigma 60, we have here 220.4 and here 259.6. Okay, and you see that when standard deviation decreases, then the confidence interval narrower than before. Okay. Now, question number C. Suppose the sample size changed to 100, but now the standard deviation sigma is same as a question number A, 78. Then we just need to change here. The margin of error is a 1.96 times a 78 over square root 100. Then let me calculate this margin of error. 1.96 times 78 over square root 100, that is just 10. Then we have a margin of error 15.288. So then the confidence interval is 240 minus 15.288, 240 plus 15.288, then we have the upper bound. So Let me calculate this lower bound and the upper bound. 240 minus 15.288. That's a 224.712. And then 240 plus this margin of error, that is a 255.288. And then let me compare with the A, answer A. Then what do you see? Well, when you compare with the A, it becomes narrower. What does that mean? When you have a large sample, this margin of error decreases. That's why you have a narrower confidence interval. So by having this A, B, C, you can see the effects of the sample size and the effects of the standard deviation. Standard deviation decreases, then the margin of error decreases. Then you have a narrower confidence interval. Question number C, you have a larger sample, then the margin of error also decreases. Then you have a narrower confidence interval, okay? Now, let's go to the next question here. Question number 4. Now it's different. You probably noticed that the second one, if x bar equals 89, but what do you see? S equals 17. That means that we don't know the population standard deviation. And then the sample size is 64. Then we cannot use normal distribution anymore. So here, we cannot use a normal distribution because we don't know the population standard deviation. Then instead of the normal distribution, we need to use a t-distribution. But formula is pretty much same. So margin of error is a t alpha over 2 degrees freedom and times s over square root n. So when we are using the normal distribution, the margin of error was z alpha over 2 times the sigma over square root n. So then when you compare these two first, or instead of the z, we are using the t-distribution. Instead of the sigma, we don't know the sigma. That's why we replace with the sample standard deviation s. So then let me calculate this margin of error. But here we have a new distribution, t-distribution. But the way to calculate the t-distribution is pretty much same as a normal distribution, but there's a new thing, which is degrees freedom. So the t-distribution is following. It's a pear shape and symmetric around this mean. In this case, we want to construct a 95% confidence interval. Then this t alpha over 2 is what? t.025. So again, 100 minus 95%, that is a 5%. And 5% divided by 2 is a 2.5%. That's why I put the 0.025. And degrees freedom is nothing but n minus 1. That's sample size minus 1. So there is 63. And then times the sample standard deviation 17 over square root 64. Okay, so I want to find this t.025 and with the degrees freedom 63. So this is a 95%. This black shaded area is a 95%. And here the left one is a 2.5%. And then the right one is also 2.5%. You can either find the negative critical value or the positive critical value, but always we use the positive critical value. So let me find the positive t critical value. So let me find the t critical value. So here I'm going to find the positive one. In order to find this one, you need to put using the Excel, and the function is following. T dot inverse, and you put the 0.975, 97.5%. Again, from the negative infinite to here is together 97.5%. So that's why I put the 0.975 and the degrees freedom 63. Then it gives me the t critical value. Okay. So let me find it. So t dot inverse, and then 0.975, degrees freedom is 63. So then it gives me the up to 3 decimal places, 1.998. Okay, so we're done. We can find the margin of error, so which is 1.998 t critical value times the sample standard deviation 17 over square root 64 is just 8. So the margin of error is a 4.245 something. So then x bar minus margin of error, that gives you the lower bound. X bar plus margin of error gives you the upper bound. So the lower bound is 18 minus, sorry, was it 18? 89, sorry, 89 minus margin of error. that is a lower bound. 89 plus this margin of error, that's the upper bound. Okay, so the lower bound is 84.75 up to 2 decimal places. 93.25, that's the upper bound. So then we can interpret the true population mean would be located between the 84.75 and 93.25, and we are 95% confident there. Okay. Now solve the next question, Q5. So question number 5, that's the last question today. So let me read the question first. A survey of the nonprofit organizations showed that online fundraising has increased that past year. Based on a random sample of the 64 nonprofits, so N equals 64, the mean one-time gift donation in the last year was $30. So X bar is $30. And 10% standard deviation is $5. Oh, sorry, typo, $5. And this is $30. So the $5, so that is a 10% standard deviation. Okay. Then you notice that, okay, we don't know the population standard deviation. That's why we need to use the t distribution instead of the normal distribution. Okay, so the first question, construct a 90% confidence interval. So X bar plus minus margin of error, where this margin of error is a T alpha over 2 degrees freedom times S over square root N. So the T critical value in this case, 90%, that means the T alpha over 2 is a 10% divided by 2 is 5%, 0.05. And degrees freedom is a 64 minus 3, that's the, 64 minus 1. N minus 1 is just 63. And then times 10% standard deviation 5 over square root of 64. So let me calculate this margin of error. So you need to find give me 1 second. You need to find the T critical value first. So put the equality. T dot inverse here. So 0.05, then you're gonna find the negative value, but we need to find the positive value. So you either drop the sign or you can put the 0.95, okay? So let me put the 0.95 and the degrees freedom is 63. So based on the degrees freedom, you will have a different number. So every time you solve this question and you are using the t distribution, then you need to calculate it, okay? So up to 3 decimal places, so 1.669. But in this case, let me just keep the full decimal places. So that being said, when you calculate the margin of error, so this T critical value times 5 is standard deviation, over square root of 64, and the square root of 64 is just 8. So the margin of error turns out 1.0434 up to 4 decimal places. Okay? So X bar minus margin of error, that is 30 minus this margin of error, 30 minus this margin of error, that's a lower bound, and then 30 plus margin of error gives me upper bound. So the lower bound is a 28.96 up to 2 decimal places, 31.04, that's the upper bound. Then I can interpret, we are 90% confident that two population mean one-time gift donation will be located between the 28.96, that means the $28.96 and $31.04. Okay. Now the last question, construct a 95% confidence interval. So in this case, the margin of error is T alpha over 2 degrees freedom times S over square root. And standard errors are exactly same as a 5 over square root of 64. But we need to calculate this T alpha over 2 degrees freedom. That is 0.025, 2.5%, and then degrees freedom is 63. So you need to calculate again T dot inverse 0.975, and degrees freedom is 63. Put the enter. Then we got the T critical value, which is a 1.998 something. And then this critical value times 5/8. Then we have a margin of error, which turns out the 1.24896 something. Okay. So the sample mean is a 30. So the sample mean 30 minus this margin of error gives me the lower bound. 30 plus this margin of error gives me the upper bound. So up to 2 decimal places, we have a x bar minus margin of error, x bar plus margin of error is 28.75 and 31.25. That's the upper bound. So then we are 95% confident that two population mean. So in this case, the two population one-time gift donation would be located between the $28.75 and $31.25. That's it.